All right, so in this video, I want to introduce the concept of an autotransformer. It's just a unique type of transformer that's basically made from a single electrical winding. Okay, so it's just a single conductor. Up to this point, we've basically been looking at two winding transformers, right? Where maybe this is my core material, and I have, let's say my primary is in blue here, and I wind this wire around a couple times, and I call that my primary, right? V1, I1. And then I'll write my secondary in red here. So we assume that there's a separate wire here for the secondary, V2. And that would have a current flowing I2. Depending on the dot convention, of course, you can define those currents however you want. But the point is that these are two separate windings, okay? And that's how we were creating a transformer before. An auto-transformer is a single winding, so just like this, I've got this winding, going around. It's basically just an inductor, and then if I tap the center of this inductor, I can use this as a transformer, because what I can do is I can make part of the winding my primary, and I can make the entirety of the winding my secondary, and I get a step-up turns ratio there, right? If I have a few turns here between these two conductors, and then between the initial input and the final winding, I have more turns, I can use that as a step-up transformer. And I can also do the opposite. So let's do this in two different colors. Let's go with green, light green for step-up transformer. So I'd have V primary here, and I'd have V secondary here. And you would agree that I have more turns on the secondary than I do on the primary. So that would basically just be a transformer. The difference is that they're electrically connected at the bottom. Okay, so that is how an auto transformer looks. They're wound around the same core, just like a normal old transformer. We can talk about the dot convention and all that good stuff. And this would be VP, and this would be VS. But because they share the same wire, they're basically electrically coupled and magnetically coupled. This is called an autotransformer. It's a single winding that we're basically using as a transformer. And so again, if we make this smaller portion of the winding our primary, and we pull our secondary out the entirety of the winding, then we get a step-up autotransformer, okay? If we wanted a step-down autotransformer, we would make our primary the entirety of the winding, and then we would pull our output from this smaller portion of the winding, because that would give us more turns on the primary than we have on the secondary, okay? And so that's the basics of an autotransformer. It really doesn't change much, except now, instead of having complete electrical isolation, we do have this node here that guarantees that basically if I can treat these nodes as normal electrical nodes. I might have, KCL at one of these nodes, and we have to take that into account, where previously I didn't have to because they weren't connected. So I know all the current, that flows into the dotted terminal flows out of the undotted terminal. But that might not be the case for an auto transformer, because I know that these are tapped in the middle, and we can actually use this and connect other components here, etc. So auto transformers get a little bit more complicated than the standard transformer, but not by much. It's really just a transformer that doesn't have electrical isolation between the primary and the secondary. And you can see how it's formed. It's just formed by using a single inductor and just tapping it somewhere, and then treating part of the winding as the secondary and the other part as the primary. And you can configure it however you want in order to get a step up or a step down, all just from a single inductor, which is actually pretty cool. Okay, so I'm going to end this video. In the next video, we'll do some derivations for the auto transformer, and then we will do an example problem, and then we're inching towards finishing up this module. Okay, so I'll wrap this video up here, and we'll see you guys in the next video.